Hi everybody, today we're going to be talking about inverses of functions, and this first page is going to talk about basically what graphs of inverses look like, and then the second page is going to talk about how does it work in equations. So let's start with the graphs. So remember that in geometry you used to reflect lines, and so in inverses we're going to focus on reflecting across the line y equals x. Line y equals x is this dotted line that starts at 0, 0, goes up 1 over 1, etc. That's my line y equals x. When we reflect things, what we're going to do is go across the y-axis. So for instance, first of all, if you haven't labeled them already, label these A, B, C, D, E. And so A is going to come across the y-axis, or the line y equals x, excuse me, and land here. So this is my A prime. Okay, B is going to do the same thing. It's going to go across this axis, this line, and end up here. So here is B prime. C is going to do the same thing and come over here and so forth. So take a second right now to finish out D and E. Okay, your new shape should look like this. And so just kind of double check to make sure your points are where mine are. A prime is at 2, 3, B prime is at 5, 3, C prime at 6, 2, D prime at 5, 1, E prime at 2, 1. All right, now that you take a look at those, let's look at the coordinates of the vertices. Each one, let's compare how does each one look in the graph. So for instance, here my B is 3, 5, my B prime is 5, 3. And if you look at all of them, that happens to all of them. And so what do you notice? What you should be noticing is that it switches the x with y. So for instance, with my B, B was at 3, 5, and that becomes 5, 3. That's what happens when we reflect something across the line y equals x. That's a key part of inverses. Okay, so that first example was really an example from geometry class. And I chose it because it's easy to draw. Like those straight lines are all pretty easy, right? But let's take a look at what happens if we have a parabola. So one of the functions is f of x is x squared. So here's my parabola. And this is the normal parabola. We talk about the 1, 3, 5 pattern. This has a vertex at 0, 0, goes up 1 over 1, up 3 over 1, up 5 over 1, etc. Its inverse, well, let's compare it to this. So first of all, we need to come up with a table of values for the g of x because it is going to match with this, but there's going to be some differences. For the inverse of g of x, the inverse being g of x, I'm going to pick some perfect squares to make it easier for us. So in other words, I'm going to choose 0, 1, 4, and 9 in my table of values because I know what the square roots of each of those are. So I'm going to take a second to plot those. 0, 0 is here, 1, 1 is here, 4, 2 is here, and 9, 3 is here. And so here is the function. This is my g of x function, the function of the square root of x. If we go back and talk about the vertices, or the coordinates, this is 0, 0, this is 1, 1. This one over here is 4, 2. And this one over here is 9, 3. And if we compare that, look, 9, 3 is really E prime, isn't it? And 4, 2 is D prime. And 1, 1 is also C prime, and 0, 0, we didn't have a number on that one. But here we have the square root of x, and it matches up at least with half of this function up here. Let's talk about what is going on and what are some of the main characteristics. I want you to just think about some of the things that we've talked about, and we're going to list those down here in this next section. But think about what are some things. One thing is we said it switches the x with the y. So this next section is going to talk about some of that. And think about what you've learned in this brief introduction here. All right, so we already talked about that. We switch the x with the y. It is a reflection over the line y equals x. Now, also, if you look at it, I think this makes sense. This bottom one doesn't as much, but let's look at the top one. Rotates 90 degrees. right? Can you see that? This is rotating 90 degrees. And also, it switches the domain and range, because it should make sense to you that if we are switching the x and the y, then that's switching the domain and the range as well. And so particularly on this function, our range goes from 0 to infinity. The range here is now the domain goes from 0 to infinity. Okay, so it's going to switch the domain and range. It uses inverse operations. So again, on this example here, we had x squared and then we had the square root of x. X squared and square root are inverse operations. So it's always the inverse function is always going to use inverse operations. Another thing to think about is it is keeping the same size. So this parabola, this polygon up here, we're keeping that same size, but we're just rotating it. And so it has a different orientation, but it is the same exact size. And finally, something to think about is it does have different end behavior. That on this first one, well, let's go with the parabola, for instance. This end behavior is going up and up, right? But this one's going to the right. So we have a different end behavior. Lastly, the inverse function and the original function undo each other. And we're going to look at that one a little bit more on the next page. But they are going to undo each other, and you'll see what I mean on the next page. Let's talk about one more thing, the horizontal line test. So you know the vertical line test. That's from before. Just a reminder of what the vertical line test is. The vertical line test is if you have a vertical line passing through the function, and I drag that vertical line across the function, it's only going to hit that function one point anywhere I go, right? However, if I turn my parabola on its side and had something like this, and now I think about the vertical line test, the vertical line test is not going to work, is it? Right, I mean, it works, but it comes out false. This is not a function because it does not pass the vertical line test. The horizontal line test is similar. That we're going to take this line and we're going to say, no, well, what if we do it horizontally instead? Well, if we go horizontally, it does not pass the horizontal line test, right? It touches it more than once, which means that the inverse is not a function. Okay, this one is not a function because this one hits it more than once, and we take a function, we flip it, we rotate it 90 degrees, and so if we rotate that 90 degrees, it's not going to become a function. Now, a one-to-one function is that every x has only one y, and every y has only one x. When we talk about a one-to-one function, do you remember when you were first learning about functions, that it was like, you know, if the 5 went to this number and also this number, then it was not a function, but yet if your little v thing was going the other way, then that was okay, that was a function. Well, a one-to-one function doesn't have any of these v's at all. They're all just straight lines. So there's just one number for each way you go. And so again, we'll talk about this a little bit more as we go, but it just means that every x has only one y and every y has only one x, which also means that it does pass both the vertical line test and the horizontal line test. Because you know, like in a parabola, the table of values for a parabola would be 4, 1, 0, 1, 4. It repeats, right? This table repeats on a parabola. That means it's not one-to-one. It's not one-to-one if it repeats like that. A one-to-one has to be a different value either way you go. All right, let's turn the page.